I'm T-Pain, and welcome to Let's Learn C++. Today is about object slicing. Object slicing is when you bust out your favorite can of lice and sprinkle it onto your TV, your couch, your hats, your clothes. Once you've covered everything you own, you share it with friends and you've mastered object slicing. Oh my goodness, that was a terrible joke. Am I getting worse? Yes. Alright, object slicing is when you assign a derived class to an instance of a base class, which removes the derived part from it. This is different than pointers because the creation of a pointer doesn't actually affect the object in memory. So it is possible to just grab the base class part from a derived class instance. Let's look at an example. Alright, so up top we have our standard setup code. Down below that we have a class called base. And this is our base class where we're just going to have some simple int data set to equal to 5. And then we're going to have a virtual print function that is just going to output base and then the data within the class. Down below that we have an inheriting class called derived. And we just have some public data that's going to override the previous data and set it to 7 and have an override for the virtual function print created up above, and it's just going to output derived and then the data, and that's it. All right, and so down below that we're going to go ahead and create some instances of this stuff. First we create an instance of derived, we print, then we set the data equal to 11, then we call the print function again. This is where base class B is being set to the derived class instance D right here. And then we're going to go ahead and call the base class print function and see what it outputs. So what do you expect this print function to actually call? Do you expect it to call this function right here? Yes. Do you expect data to be 5 or 7 or 11? What do you think? Let's go ahead and run it and see what happens. And what it outputs is the derived class is first being set to 7, which is what we expect. Then it's printing out 11 after we've adjusted the data. But then our base print function is being called and it's outputting 5. The original data is actually being preserved in the base class instance and not being overwritten by the derived class. Very interesting. All right, so you may be looking at this example and being like, this actually seems pretty silly. I'm never actually going to intentionally do this, but you are very likely to do it accidentally. And here is why. So I'm going to go ahead and trim down all of this to be a much sleeker example. So we have our base class up above. It just has the print function. Derived class just has the print function as before, but no data is being stored in it now. And we have this function called void printer. And what it's going to take in is a base class instance, and then it's going to call the print function. So down below, we're actually creating a derived instance and passing it into printer. What do you think it will print? Well, it is a derived instance, but as we saw before, we're going to be object slicing. We're going to be taking the base class portion of it and calling that print function. So if we run it, you will see that the base class print function is actually being called instead of the derived class. Now, if we had set this to be a pointer instead, then we can actually call the print function properly, as we've seen in various other examples, what we learned about in our virtual module. All right, so according to C++ core guidelines, C.37 says a base class should suppress copying and provide a virtual clone if copying is necessary. So the long and short of it is, if you're going to be object slicing, instead to try to create a copy and stop the base class from ever being copied itself. So I'll show you what I mean. So here is one of their examples in a slightly different form than what they have on the core guidelines. So in the beginning, you would suppress the class from being copied, which gets beyond the scope of what we know right now. It involves operator overrides, which I haven't covered yet. And that would just basically stop the class from ever being copied over. And then we're going to have our print function just as before. And then here we're going to have our function called clone. This is actually a design pattern. We'll cover it much later, but it's basically returning a new instance of base. And this solution right here is not a very good one because we're returning a loose pointer rather than actually making it a unique pointer or having an owner or anything like that. And so if we set that pointer equal to something else, then we'll have this object floating in memory and it'll result in it never actually properly being deleted. So loose pointers are bad. basically. But we'll get into that later with dynamic memory allocation in the next tutorial. All right, and then in the derived class, we just have overrides for the clone and print functions, and that's pretty much it. So down below that, we just have an instance of derived being created, and then we call the clone function and then set a base pointer equal to it, call the print. What do you think this print will call? It is a base pointer, but it's calling the print function. And remember, pointers are different than actual instances. Since it is a base pointer and we're calling the print function, it's actually going to call the lowest most instance or implementation of that. So the derived class print function would actually be called. And then below that, we have our instance of base class being set to D and then calling that. So what do you think that would call? That would call the base classes function. All right, so let's double check that to see what's going on. And indeed, everything we said was exactly right. First, we have the one or base one pointer being set to calling the print function for the derived class right here because it calls the bottom most. And then we have the instance of the base class calling the print function, and that's going to print out base. Perfect. That's exactly what we would expect. Now again, be warned, this is not a very good solution for the problem, and we will discuss better solutions in the future. But that is it. I'd recommend challenging your skills at hackerrank.com, and special thanks to my Patreon supporters, JK, Marcus G, Yu Cheng H, and as always, like, subscribe, and keep the dream alive.